The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the hosts, guests, and presenters.
LED lights now are so intense that they turn me away. I'm having to shield my eyes. I may turn around. It's a barrier for me to get through because it's too intense. If it's flashing, it's worse. So I may go into a panic attack, and my vision is impaired, my cognitive abilities are impaired, I panic.
I think, a possible solution to all this, I don't know for sure, but I think we need to really start to consider induction lighting. And a lot of people, think, induction was the ugly sister of LED and it got destroyed. But there actually is induction lighting manufacturers out there. One of them is called Tesla Induction Lighting. You go to teslalightingco.com. That's TESLA lightingco.com. And they have a whole range of outdoor light fixtures that you can check out there. And, induction lighting is a lot different than LED. It's a different light source. And I was talking about, on the show that we really don't know what electric light is, but we know how we react to induction lighting. We know we've had enough induction lighting out there that we never had these sensitivities. We never had these sensitivities to fluorescent. We never had these sensitivities to HPS, metal halide, incandescent, halogen, or induction. We did have some sensitivities with T12 when it ran on magnetic ballasts, yes. Dr. Arnold Wilkins did a lot of work on that and proved it. But we seem to have issues with LED. And so if you're in one of these situations and you need a solution, you can check out teslalightingco.com. Check out the fixtures they manufacture. And maybe there's a situation where we can start trying this stuff out a little bit and seeing if people that are struggling under LED lights are saying now that they have relief. That would be interesting to see. And so there's a lot of examples out there. And so I want you to go to teslalightingco.com and I want you to consider it. I mean, the profile of induction in terms of life, longevity, is about the same as LED, if not better. And then on top of that, I don't remember a lot of failures with induction lighting. And I know that there's lots of failures with LED. Now, could that be because I just sold way more LED than induction? That's possible. Yeah, that's possible. But I'll tell you, man, the gym I worked out at, they got 15-year-old induction lights on sensors. Walk in, the lights come on, same lights. Actually, the owner there thinks they're LED. It's hilarious. He's like, I got my LED lights. I'm like, okay, good, got LED. So I don't argue with people unnecessarily, as much as people think I do, I guess. So teslalightingco.com. Also, if you want to support the Restoring Darkness podcast or you want to support Soft Lights Foundation, you can go to restoringdarkness.com and click the donate link. And then what you're going to see is you have the ability to donate directly to the show. Now, that would be the production costs. That's right. It costs money for Scott, the producer. It costs money for licenses and getting guests and all the work we do here to keep this show moving forward. So feel free. I don't do monthly donations to anybody. I don't like that kind of subscription stuff, but you can do it there if you feel like you want to give $10 a month or $5 a month or $100 a month, whatever it is you want. Or, maybe you could give, a one-time donation. And, if you want, we'll bring your name up on the show. We'll give you some credit for it. Or if you want to support Mark Baker's work, you can click the Soft Lights link and you can donate directly to Mark Baker and what he's working on and all the Soft Lights update that we do. He needs money for that. He spent a lot of money on this issue. I'll tell you that. I know for sure. Of his own money. And he could use $1,000 or $500 or $100 or $5 or whatever it is that you can give. Sometimes it's okay to acknowledge that our only way to participate in an issue, our only way to help out is to give money, to give our resources. Sometimes we can't give our time. Sometimes we don't have the knowledge to be we can't volunteer. We got kids. We're busy. All this kind of stuff, right? We can't all do everything, but sometimes we can give some money. So feel free doing that. There's no pressure from me. Also, you can like and subscribe and share this show with other people. Go onto our social media feeds and see what we're putting out there and promote it. Because I'll tell you this, none of us get paid, Mark or Michael. We don't get paid to do this. We're volunteers. And we don't intend to get paid to do this anyway. So I want you to check out Tesla Induction Lighting. I want you to go to restoringdarkness.com. I want you to share our social media if you can. And feel free to make donations. Thank you for listening. Welcome back to the Restoring Darkness podcast. I'm Michael Colligan, and I'm very pleased to be joined by my friend, my colleague, and the president of Soft Lights Foundation, Mark Baker. Mark, it's just you and I today.
Hi, Michael. Yeah, it's a good chance for us to catch up and talk a little bit about things we've learned over the past few weeks.
The first thing we got to do, though, at the beginning of every show is we need the soft lights update. What are you up to these days, Mark?
Well, let's see. Let's give you something that's exciting as far as reaching out to public entities. So it turns out that in the Americans with Disabilities Act, there is a section in there that says something like, if you're a public entity, you shall modify your policies, practices, or procedures to eliminate any discrimination. And you must do that unless doing so would somehow fundamentally alter your services, programs, or activities. But the word shall in legal terms means must. So we have a new initiative where I have written letters, and I've sent them now to all the University of California educational institutions, UC Santa Barbara, UC Davis, UC Irvine, and I've asked them to modify their policies, practices, or procedures to include the issue of LED light discrimination. Right now, their policy is to ignore LED light discrimination. So I've asked them to update. A couple have responded and they said, oh, okay, and they turned it over to compliance. Do you remember we talked about compliance the other day? Compliance, right. So they're not thrilled with my letter, but we'll see. So it's a new initiative, but it's extensible. So I started to notify school districts in California, and we can do this state by state. So let's get government entities to start recognizing LED light discrimination.
It's an interesting angle to approach it from. Describe some of the ways in which LED lights discriminate against people, Mark.
Well, I can talk about myself. So if I am trying to navigate, and in the United States, the ADA path of travel is a very important term, path of travel. So path of travel, originally when the ADA was put together in 1990 and the update in 2008 was, is there a barrier in your way related to your disability? Oftentimes it's wheelchair access. So a curb cut on a sidewalk. So if you can't get onto the sidewalk because you're in a wheelchair, then that's a barrier to your path of travel. Well, for me, LED lights now are so intense that they turn me away. I'm having to shield my eyes. I may turn around. It's a barrier for me to get through because it's too intense. If it's flashing, it's worse. So I may go into a panic attack, and my vision is impaired, my cognitive abilities are impaired, I panic, and it's different types of lights. It can be an intense light, like these blue lights on the video surveillance systems, but it can be even at nighttime, the blue rich LED street lights. It's a psychological trauma that I'm suffering. Other people that have disabilities, such as people with epilepsy, may suffer a seizure. That's certainly a discriminatory barrier interfering with their path of travel. So when we say modify your policies, practices, or procedures, instead of having basically a de facto, well, we don't do anything about LED light discrimination, it should be a policy. The United States runs on policy. So write it down. What do you do? If your solution isn't the best, okay, that's fine. But at least you got to have a policy, and the federal law says you got to have a policy.
And so we've had people on this show that have flat out told us that they can't drive at night. You know, these are issues now because of the headlights and also because of the street lights. Under bridge lights can be particularly bright and cause visual acuity to be reduced, particularly in older individuals. Where is the fundamental issue here? Is it, in your belief, do you think it's simply the source? LED light is the problem?
Well, as we've talked about before, there are multiple problems with LED lights. And I've recently communicated extensively with our previous guest, Larry Boxler. He's an optical engineer. He's helped me a lot to understand some of the problems with LED lights in terms of the spatial distribution. But we have not only the spatial distribution problems, but we have the digital flicker, which is a major problem. It could be in the LED headlights, but that pulsing that some of us can see and some of us don't see, but it's still there, is a major issue. And then, of course, the spectral distribution, the lack of the infrared and the blue rich color. All of those things are causing problems. LED is so different than any previous light source. So just to explain a little bit what Mr. Boxler explained to me about the LED lights, when it also comes back to standards. So for example, when the roadway engineers measure the light, they measure it with a lux meter, the light falling onto the roadway surface. That's been the IES standard, how much light is falling onto the roadway surface. The big difference with LEDs is that the light is coming from a tiny chip, small source, and the angle is like 120 degrees or something like that. It's a smaller angle, and you put those together, it's called étendue, and there's no regulation on this sort of small source, small angle, and the high luminance. Not illuminates now, but luminance. And what I'd been missing for years now that Mr. Boxler helped me understand is that I was missing that when the light comes from the LED, it goes through our lens of our eye. The lens refocuses that light. So it was dispersing and then it comes through the lens and then now it's refocused onto the retina. I had just considered just the image part. Okay, great. So it goes through the lens and makes an image. But not only that, it's recreating the luminance, the intensity of the LED. It's recreating that. And so there are no standards for the luminance or, in this case, the illuminance on the retina. All the standards from IES are the illuminance on the roadway surface. There is no standard for the illuminance on the retina. So when you've mentioned it before on this show many times, when you're driving through and the LED streetlights are hitting you over and over again, that's because there was no standard for that direct light coming through the lens of your eye and then creating this very dense, sharp image on your retina. So when the physicists use this term, I've heard this many times, oh, your eye sees, they always put in quotes, your eye sees luminance. I couldn't understand that because that's far away. How could your eye, quote, see luminance? It's because the lens of your eye, that's why. It recreates. And so without a standard look anywhere, where's the standard for the luminance? And it's not there.
Consider induction lighting again. TeslaLightingCo.com. I often wonder to myself, and I think it's true, and I've said this openly, that I don't believe the lighting industry knows very much about light. I'm not talking about how to build a light fixture. I'm not talking about measuring foot candles on a road surface or a sports field or whatever. I don't think they know what they're looking at. I don't think they know what they're measuring, what it is. There has to be a massive difference between HPS, high pressure sodium, and LED light. There has to be a difference between those two things. They have to be chemically different or partically different. They have to be. And the lighting industry, I don't think, sees that. I don't think it considers that incandescent and HPS and metal halide and induction and fluorescent are actually different things. They're not the same thing, Mark. And LED light, you mentioned temporal light modulation. I think you call it digital flicker. These other sources don't do that. And these other sources don't have this high luminance. These other sources are reflector based. So they're basically like a fire. They're creating some kind of combustion. And that combustion is reflected off a piece of aluminum or metal or like a glossed up metal. and it's pushed out of the light fixture. That's not the same thing as an LED. I don't think I don't think they can be compared. Now, do people say that electric light is electric light? Sure, maybe that's what they say. Is moonlight and sunlight the same thing? Obviously, it's not. The light from the moon comes from the sun. It's reflected off the moon. It's it's a different color. It comes back as a different color temperature. It is much softer. Even when it's bright, it's soft. So there's something different going on with LED that is not like other sources or conventional sources. It's different. And I think the lighting industry needs to acknowledge this. This first step is that LED light is different and it has different characteristics and it affects living things differently. And I don't know why we won't do that. I don't.
Right. So I've talked to a few physicists recently, or I've communicated with them, and they tell me that, well, the Illuminating Engineering Society knows these issues. They just have chosen. These physicists have written to them and said that there's these differences, and they've actually made a decision not to address the issues. So, some physicists
Now
will
that's
say,
hearsay. We don't know that. That's not in writing. We're not saying that we know that to be the case. But
I'm just telling.
you have heard from eminent researchers and physicists that they have reached out to the IES, and the IES has declined to comment or refused to acknowledge something along those lines.
Correct.
Sounds familiar
Right.
to me.
People that I know personally have told me this. So,
Are they willing to come on the podcast and talk about it with us?
I don't know. I couldn't speak for them.
Can you ask them? Because I'd love to have them ask that on the show. Like Mario
Okay.
Mata. Mario Mata, when he
Yes.
came on, he stirred up a hornet's nest, and that hornet's nest is still out there. It's still going. So I think that someone that could say, listen, I'm a physicist. I research at X university. I have a PhD or whatever, and I reached out to the IES and I said this to them, and they did not respond or declined to comment or whatever. I think that would be very important to move this conversation forward.
It is. So now's a great opportunity for me because people might listen to this who are in the industry. So I had been, when I first got into this, I have a degree in electrical engineering. So it's not like I'm untrained, but lighting was not my focus. I only got into lighting because of the impacts of LEDs on my life. So as I tried to learn about these differences that you just spoke about and was unable to locate information on the internet, it was very difficult to understand. So I had to get information from people that I came across, and not everybody had patience to sit me down and teach me because not everybody even knew how different the LED light was. I've been doing this for 10 years. So there are these terms in the lighting industry that turn out to be very ambiguous and loaded with assumptions. Terms such as inverse square law, Lambertian distribution, and point source in particular. They are not well defined. Nobody seems to have an exact definition. They become amorphous when we start try to pin down what they mean, and people start waving their hands and such as to what these terms mean. And so I had been focused on, through what I had learned, I had been focused on this Lambertian distribution. And this caused a lot of friction with physicists and engineers in the industry because the mainstream was not thought that had nothing to do with the issues of LEDs. So when I communicated with Larry Boxler, who's an optical engineer and quite talented, and he's worked in the different fields and he uses modeling software, he's the one that helped me understand that, well, these terms are ambiguous and there's lots of different ways to look at them. But really, the lens of the eye is probably more of a factor, much more of a factor than the Lambertian distribution, or whether it is isotropic or anisotropic. That's not as important. And so I did communicate with a number of physicists that I had been having strife with, I would say, who are all trying to help me understand some issues. And I guess I was having trouble hearing what they were saying because I had this other vision of how the light works. So I feel that I've patched up my relationship with a number of physicists out there and engineers that work in this field. And now we can move forward with regulations and standards, and now we can sort of work together and to try and help standards organizations such as IES, CIE, IEC, IC, NERP, whoever, to understand these differences and that something needs to be done to set regulations for LED light.
Whew. Thank you for listening to Restoring Darkness. This has been Michael Colligan and Mark Baker. I think that's a great place to call it, Mark. I want you to consider for a moment something other than LED. I want you to think about induction. I know everyone thinks it's LED's ugly sister that died when she was young, but it's not. There's still a lot of induction lighting manufacturers out there. One of them is TeslaLightingCo.com. Check them out. They have a whole product line of induction light fixtures, indoor, outdoor. Now on this show, we're talking about outdoor lighting primarily. But induction can be made in low Kelvin temperatures. So if Kelvin temperature is your concern, you can get induction made in low Kelvin temperatures. It can be shielded, just like HPS, metal halide, and LED. You can shield induction lighting. You can have low Kelvin temperatures. Induction lighting is instant on, instant off, just like LED. So it works. It doesn't have a warm up time like HPS and metal halide. And it's not LED light. And so I'm not saying that induction is the solution to all of our problems, but I think it's time for specifiers, designers, and engineers to start taking a second look at induction. You can do that by going to TeslaLightingCo.com. I know the owner there, Philip, he's a great guy, and Mike and the team there. They do a great job making light fixtures. And I know from my personal experience that I've seen induction lighting perform for a long time, and I've seen problems with LEDs. So go to TeslaLightingCo.com. Check them out.